Khoshnevis. If you are able to share your screen. Yep, and so Behrokh is the president and CEO of Contour Crafting and also distinguished professor of engineering and the director of the Center for Rapid Automated Fabrication Technologies at University of Southern California. In my mind, he is one of the first pioneers in the field of 3D printing for construction. And when I was doing my studies at Stanford, was the one that clearly appeared as the foreleader, especially in the United States. So Behrokh, we're very pleased to have you, and we can see your screens. So please feel free to begin. I think the only thing we don't see. No, we're ready to go. All right. Thank you.
Very well. Can you hear me?
Yes, looks good and sounds good.
Wonderful. Well, good morning, good evening. Today I'm going to basically give you a brief overview of what we have done and where I think the concrete 3D printing technology is going to go and its challenges. Okay, I am trying to advance my slides. All right. Well, 3D printing has been around a little bit over 3 decades, and you have seen its applications in many different domains. The materials started with polymeric materials, and then into metallic and ceramics, and finally into composites. I have been very active in 3D printing field for nearly 3 decades. I have developed different technologies. One of my focus areas was polymeric 3D printing at the beginning, and then metallic, developed technologies that are licensed by Hewlett-Packard, HP. But in 1994, right after the earthquake in Los Angeles area, it occurred to me that 3D printing builds layer by layer, and that the only structure that we have built in a layer-wise fashion are really buildings. This building was 3D printed actually 2,500 years ago. It was made with adobe material, clay and straw, and it still is standing. So I was back then convinced that maybe the real potential of 3D printing is in building construction, not in manufacturing. In manufacturing, 3D printing has advanced a lot, but it never meets the capabilities of conventional manufacturing processes with respect to surface quality, accuracy, material integrity, and so on, the structural integrity. But in construction, for the first time, we can have, for example, millimeter accuracy in construction, and higher speed, of course, and possibly choice of different materials. I guess 2015, I was recognized by a Dutch independent group as the originator of this whole field of large-scale 3D printing. And as you see, the number of groups, research groups, and now industries in the field is exponentially growing, which is very good news to me. So over the years, I've been active in developing different aspects of technologies while I was at University of Southern California. And I developed many different technologies and numerous patents. I got the first hybrid nozzle that could create hollow walls with corrugated internal cavity, was done in 2006. And we did a number of experiments and demonstrations. These are some of I'm not sure if this video can be seen or not. These are some of the experiments that we did, mostly in-house, not on site. And we have since developed technologies that have special capabilities not yet realized by others. And these are some of the demonstrations that we made. And we have been active also in space applications. The two of the large scale 3D printing systems that I developed, contour crafting and selective separation shaping, won NASA international competition grand prizes for capabilities for construction of different elements of human outposts on Moon and Mars. And in 2017, summer of 2017, I created the contour crafting company with a investment from a European multinational concern. And our goal here is basically developing technologies for different sorts of buildings. This is our vision. So why construction needs change? I assume all of you are really familiar with the rationale. It's the largest sector of almost every economy. Labor efficiency is very low in it. Skilled workforce is vanishing. Work quality is low. Control of construction site is difficult. Accident rates are pretty high. Waste and trims are high. And low-income house and emergency shelters are critical. And finally, all other products are fabricated automatically pretty much. Construction of buildings is still largely done in a manual way. And productivity in construction is pretty low. It's actually been declining while productivity in manufacturing has been going up. The value-adding portion of manufacturing activity is pretty high portion of the entire endeavor, while in construction it is the opposite. And we know that there is a lot of shortage for low-income housing, and disasters, national disasters are on the rise because of the environmental changes, and of course, unfortunately, the situation with refugees. So at least in the housing sector, there is a dire need. But there are barriers against implementation of 3D printing construction. Construction industry is a very conservative one, and for good reasons. Typically, projects are done through contracts, and profit margin is small, and therefore investment by construction industry in R&D, as I have learned, is pretty rare. Then the regulatory obstacles, of course, are another issue. Right now, we are trying to get certification under the International Code Council supervision for our technology, and especially in California, which is seismically very active. It is very difficult to pass these tests that are required. At best, only the cost and time of building of the shell is impacted by 3D printing. 3D printing really does not complete the entire building, but it basically builds a shell, the concrete shell. And that's maybe 15 to 25% of the value of the building. So the impact is really not as huge as it is shown to be or claimed to be. The material used, at least currently, is expensive. It's several times the cost of real concrete or conventional concrete. Uh, and that's one area that we have been trying very hard in my company to address. That's a problem. Um, the 3D printing construction requires expensive asset, which is the equipment. And in many countries, for example, home builders are pretty much small companies, a lot of mom and pop construction companies. In the United States, as I have heard, there are 38,000 of those companies. And these companies cannot easily afford such machines, and even if they afford to buy it, the operating maintenance cost of it and storage costs, are additional costs that in normal situations such companies would not incur. Typically, there is a construction opportunity, the project, they bid and they get it. They quickly assemble a team, hire a team of workers, a lot of them low paid workers. And then after they are done, they have no obligation to those workers. They just lay them off, and they have no equipment to store anywhere or maintain anywhere. And of course, with that equipment comes the need for specialized talent to be able to operate those. And they cannot easily just ask those guys to leave, because they may not have an easy time finding them again when there's another opportunity. So there are a lot of subtle issues related to the concern for commitment by construction companies to this technology. Another major issue, of course, is inspection. In the course of building a house right now, 10 to 12 times from the city, they come and check different aspects of construction. How can you handle the inspection when you can, for example, build in one day? So that by itself is really requires a new paradigm in technology and in regulations. And of course, in certain areas, labor unions could pose an opposition. So these are challenges that, in my opinion, construction 3D printing will be facing and is facing to a certain extent. So the applications that previous speakers mentioned are promising directions. It is not necessarily only building constructions, but infrastructure construction. This project we have had for developing a technology for building tall towers for wind turbine. For example, is one kind of non-building application. Maybe the building codes would be less stringent because these things are built in not very populated areas. Of course, another application is the space technologies for possibly building on Moon and Mars. As I mentioned, we've been active in this field, working under several NASA contracts, and we are continuing that line of work. Well, with that, I end my presentation, and I would be happy to respond to questions, I guess, during the panel. We're running a little bit late, so I made it short.